part of earlier topics, we have created tables using schema that is determined from data frame or from the file. Sometimes we might have column names and data types, but we might not have data from which the schema can be determined. Let's understand how to build the schema using column names and data types provided and use that schema to create the table. When we want to create a table using spark.catalog.createTable or using spark.catalog.createExternalTable, we need to specify schema. Schema can be inferred, or we can pass schema using StructType object while creating the table. StructType takes a list of objects of type struct field. For each and every field in our table, there will be a struct field object associated with it. Struct field is built using column name and data type. All the data types are available under PySpark.sql.types. Once we build StructType, we can use it as schema, and we can invoke spark.catalog.createTable along with the table name. If it is spark.catalog.createExternalTable to create external table, on top of name and schema, we also need to pass the path. Let's start the Spark session. Once this Spark session is started, we'll also set the property called as spark.sql.shuffle.partitions to 2. This will take care of using limited resources while managing small datasets to explore the scenarios which I'm explaining here. Now let's perform few tasks. The first task is to create empty table using spark.catalog.createTable or using spark.catalog.createExternalTable. We'll be using spark.catalog.createTable. As part of that, we'll be creating database by name username _HR _db. In my case, it is itversity _HR _db. If you are using your own cluster, you might not have to specify this prefix, but as ours is a multi-tenant cluster, we have to specify this. Otherwise, there might be database already with just HR _db. Once the database is created, we'll be creating a table by name employees with following fields: employee ID of type integer, first name of type string, last name of type string, salary of type float, nationality of type string. Let's create the database first. I'm creating an object called as username. It will contain the details about the user that is used to login, which is nothing but itversity in this case. Using this variable, I'm creating the database. So in this case, itversity _HR _db database will be created. You can run this and it will take care of creating the database if the database doesn't exist. You can connect to the database using set current database that is exposed on top of spark.catalog like this. You can run this and it will take care of attaching this session to that database. You can actually run spark.catalog.current database to ensure that we are attached to the right database. I have to specify circular brackets like this and then run this. You can see that this session is attached to this database. Now you can get the help on create table. As part of create table, we have to pass the table name, optional path, optional source, schema, and additional options. In this case, we will be using schema to pass the schema using StructType object. Let's get into the details about building the StructType object. In this case, we have mentioned that employee ID is of type integer, first name, last name, and nationality are of type string, salary is of type float. So we need to import these three types from PySpark.sql.types. You can see here, I have imported string type, float type, integer type on top of struct field and struct type. Even struct field and struct type are also part of PySpark.sql.types. You can run this. Based upon your requirement, you can explore the additional types and you can import those additional types. Now you can see that we have created a list of struct fields. In this case, as part of StructType, I am passing list. The list contains struct fields. Each struct field contains the column name and associated data type, which is nothing but the types that are imported from PySpark.sql.types. This is how you should be able to define the schema. Now employee schema is of type StructType with these list of struct fields. We should be able to create the schema by name employee schema. You can run this to preview the schema. You can get the details here. It exposes additional functions which you can leverage. For example, if you say help and then paste this schema object, you can see there are additional methods. You have add, you can add more columns, I guess. You can get the field names. You can get the JSON value of it. You can get a simple string, so on and so forth. For example, for logging purposes, if you want to just get the string part of this object, you can use simple string function. Let me clear this output. Then say employee schema dot simple string like this. Now you see the details of the schema in the form of a simple string. Now I'm dropping the table if it already exists. This will take care of dropping the table for us. I'm creating the table by passing StructType object as schema. You can see that I'm invoking spark.catalog.createTable, passing the table name as first argument. As part of the second argument, I am saying schema equal to employee schema. So using this schema, this table will be created as part of the Metastore. You can run this. Once it is successfully returned, you should be able to list by running this piece of code. You should be able to see the table. Table name is nothing but employees. Database is nothing but itversity HRDB. Table type is managed. It is not a temporary table. That's why is temporary equal to false. You can also get the columns of this table by using list columns like this. You can see all the details related to columns. We have 5 columns in the table. They are nothing but employee ID, first name, last name, salary, and nationality. You can also get the data types of the columns here. Employee ID is of type integer, first name, last name, and nationality are of type string, salary is of type float. It have additional information as well. You can review it. You can also get complete metadata of the table by running the Spark SQL query using spark.SQL like this. You can run this. It will give you the output related to this table. It not only provide you information about columns and data types, but also the location in which the table is managed. With respect to this table, the location in HDFS is nothing but this one. It also provides you metadata about the file format. As we haven't specified a specific file format, it have used default file format, which is nothing but Parquet. This is how you should be able to define schema while creating the tables using StructType. StructType takes a list of struct fields. For each and every column, we have to create a field object and we have to pass the list to StructType to get the schema. We can use that schema to create the tables by using a schema keyword argument.